All right, guys. This is a little bit different way that I've done these videos in the past, but hopefully it will work out. This is your Friday paper 14 that's due Friday, November 20th. And I'm going to start by working on problem number 3 on this Friday paper. So I'm going to go down here to where you can see my work. All right. So for number 3, we're going to find the product of 6.592. So 6 and 592 thousandths times 600ths. Now, notice I left out the decimals and I left out this 0 because I'm going to just go ahead and multiply. Okay, then we'll figure out what to do here at the end. So let me zoom in just a little bit. So I'm just going to straight up multiply. 6 times 2 is 12. 6 times 9 is 54, plus 1 is 55. 6 times 5 is 30, plus 5. And 6 times 6 is 36, plus 3. Okay, now I have to figure out where these decimals go. So I'm going to go ahead and add this 0 and this decimal point here, because remember, if I were to just make another line here, it would just be a bunch of zeros, right? 0, 0, 0, 0. I don't need it, but I do need this, and I do need this here so that I know how many decimal places I'm dealing with. And I need this decimal here. So I'm going to count how many decimal places after. So here, 1, 2, 3, 4, 5, a total of 5. 1, 2, 3, 4, 5. Okay, let's go ahead and put a 0 here. So my answer for number 3 goes up here. All right, let's move it down. And it's 0, 3, 9, 5, 5, 2. Okay. So that's going to be my answer for number 3. All right, so the next one we're going to look at is number 7. Okay, I'm going to zoom out over here just a little bit. So for number 7, this is going back to these monomials here. Monomial divided by a monomial. So we remember the division rule for monomials is if I have x to the a over x to the b. In other words, the bases are the same. Then I take the exponents and I subtract them, but it must be this numerator one minus the one in the denominator. And then if I get a negative, so if I have some base raised to a negative power, right? So negative a, I change that, this is my rule, to 1 over x to the positive a. So I really need both of these rules here, because if it's going to be a negative, I'm going to have to move it into the denominator, right? So I'm going to go ahead here, give myself a vinculum, and I'm going to say j and j common bases, 6 minus 1, that's my 1 there, is a positive 5. So j goes on the top because I've got a positive 5 exponent. But for k, I end up with 4 minus 7, which is a negative number, right? 7, 4, 3. So it's going to end up to be a negative 3. If I end up with a negative exponent, I drop it into the denominator to make it positive. If I leave it negative, it's not going to be simplified. So it becomes k to the third, that's down there. And then we have m to the first and m to the second. So 1 minus 2 is a negative 1. So negative 1 becomes positive when I put it down here. And that's m to the first, but I don't need that 1 because it is, it's implied, right? Because we have anything by itself is really to the first power. So my answer for 7, I'm going to go over here to number 7. J to the 5th over k to the third m. Okay, so that's my answer for number 7. So now let's look at number 8. So we're multiplying monomials, right? So monomial here and here. And the numbers that are before it are called the leading coefficients. Okay, so here there's a leading coefficient greater than 1, there's a 2, and there's a 7. All right, so we're going to take those and we're going to actually multiply the leading coefficients, multiply those. So 2 times 7 is 14. And then the rule for multiplying with coefficients is if I have x to the a and I'm multiplying it, by x to the b, so these are the exponents, the shortcut is I add the exponents. Okay, so I'm adding them. So the like bases, e and e, I have a 2 and I have a 4, so I add those and I get e to the 6th. F and f, this is a 1, right? Because that's implied. So 3 plus 1 is 4. So f to the 4th. And then the common bases of g, I have a 5 and a 2. So I get g to the 7th power. Okay? So that's my answer for number 8. 14, e to the 6th, f to the 4th, g to the 7th. Okay? Now let's go down and I want to look at number 9a. Okay, so the directions say determine if the following equations will have one solution, no solution, or infinite solutions. Okay? Now the the shorthand of saying no solution is an O with a line through it. And that actually means empty set. But another way of referring to it is no solution. And if it has infinite solutions, we can use that 8 laying on its side, that's infinity, okay? So we might want to go ahead and we can either write these out or use these here. If it has one solution, I'm going to get x equals something, and I'm going to get some number there. Okay, so let's check it out. So for this one, let's go ahead and start the process, and we've learned this in class, how to deal with variables on both sides. So I'm going to subtract x from both sides first. And I have 2x minus 1x is just x. I'm going to bring down my positive 4. These are additive inverses, so they're gone. And what's left is a negative 8. I have to bring down that negative. I'm going to go ahead and subtract 4, right, from both sides. Additive inverses make 0. So x equals negative 8 minus 4, which is a negative 12. So I ended up with one solution here, right, for number 9a. So I could either write one solution, right, or I could, sorry, you can't see that, one solution, or I could just go ahead and solve it, which is probably the best thing to do. So x equals negative 12. That's what we're going to put for 9a. So let's look at 9b. So let's go ahead and start our process of solving. I have like terms 4a and 4a. Okay, so I'm just going to go ahead and subtract 4a from both sides. Now notice additive inverse, additive inverse. So these are both become 0. So I'm left with negative 6 is equal to a positive 8. Is that true? No, never. Never will that be true. So I'm going to go ahead and cross out that equal sign. I'm making this symbol right here. That means is not equal to, right? If I get a situation where I have these two sides are not equal to each other, that's no solution. So my shorthand for number 9b is no solution. Okay, let's go ahead down to 10a. right here, we have parentheses. So that means we have to use the distributive property first. So 3g, and then 3 times negative 9 is negative 27. And we're going to bring this down. 3g minus 27. Do you notice that I have expressions that are exactly the same on both sides? Whenever I get a situation where I have expressions that are exactly the same on both sides, then I know that this has infinite solutions. So no matter what number I put in for g, it's going to come out to be equivalent. So I could put anything in. So the way that you can also do this, if you want to work it all the way out, subtract 3g, those are 0, and I get negative 27 is equal to negative 27. That's true. I could add 27 to both sides. Additive inverses make 0, so I end up with 0 is equal to 0. If you work these out all the way down and you get 0 is equal to 0, which is a true statement, you know that you have infinite solutions. So for 10a, I have infinite solutions. And again, I didn't have to work it all the way out. Once I see that I have two expressions, this one and this one, that are exactly the same, I can stop because I know that that's infinite solutions. All right, let's go to 10b. And for this one, wait, I'm trying to look where I'm going to put my line. And what am I looking for? I'm looking for an equal sign. Is there an equal sign here? No. So I do not have an equation. So in order to have an equation, see, equa, I need to have an equal sign. This is not even an equation. So automatically, there's no solution. But what I could try to do is simplify this, right? That's not what the instructions are asking me to do. But all I actually could do, if this was a math problem, it would say simplify. And I have 3 minus 13, and that's going to give me a negative 10. But that's as far as I could ever go with that, because I have no idea. It's not an equation. There's nothing to solve. And I have not been given x. If they said x equals 2, like if I'm told that, they define x, then I could say, well, 8 minus 10 is negative 2. And that would simplify it further. Or I would be evaluating, but I can't do that. So because this is not even an equation, my answer here is no solution. Can't solve an expression. Okay, the last problem I'm doing on the video is number 14 on the back. Okay, so number 14 is right here. And this is an equation. It has an equal sign. But I thought you might like to review how to do these. This, I want you to just think of, here's an expression, and then it's being divided by 3, right? So it's kind of like c over 3 plus 4 over 3 is equal to negative 9, right? We could think about it like that. But an easier way to think about it is just to think about this as division, and I undo division with multiplication. Okay? So 3 over 3 makes a 1. 1 times c plus 4, multiplicative identity property says c plus 4 times 1 is just c plus 4. And then I have negative 9 times 3. So what I do to one side, I must do to the other side, right? So c plus 4 is equal to negative 27. And let's go ahead and subtract 4 from both sides. Okay? So c, because these are additive inverses, they make a 0. C is equal to 27 negative 4. I have to add those, don't I? It's going to be more negative 31. Negative 31. Okay, so there's my work. And then I'm going to come over here to number 14, and I'm going to say C is equal to negative 31. Okay. All right, so there you have your problems for this week's Friday paper. And before I sign out, I want you to remember something that you normally, I think I'm going to write it the same way that it's written in class. Okay, it's on the top of my board. I want you to say this to yourself. I'm important, and the world needs me. Say that to yourself. I 100% believe that about you. You're important and the world needs you. I need you. I wish you were here and I wish I could see you. So say that to yourself and remember that I love you, and I will hopefully see you on Google Meet tomorrow, and I hope you have a great day.